This is the chapter 10, 10.1 mini lesson. So first of all, the triangle sum theorem states that the sum of the measures of the interior angles of a triangle always equal 180 degrees. Doesn't matter what the triangle looks like, that will always be the case. So I'm going to give you some drawings that we're going to mark in, and we're going to try to look at angle relationships and side length relationships. So here it tells me to draw an acute triangle. It means all three angles are acute, which means they're less than 90 degrees. So I just kind of freehanded these. I have a 70-degree angle, 60-degree angle, and a 50-degree angle. And then you have to match these up appropriately. Across from the 70-degree angle is 4 centimeters, across from 60 is 3.5, and across from 50 is 3. And what the rest of this section talks about is wanting you to see that when I look across the biggest angle, that will be the longest side. And when I look across the smallest angle, this will be the shortest side, which means the middle angle, this will fall between those two measures. So that happens when we have an acute triangle. But if we skip ahead here to 2, we want to draw now an obtuse triangle. An obtuse triangle has one obtuse angle. So again, I kind of freehanded this. I have a 110-degree angle, I have a 45-degree angle, and I have a 25-degree angle. So those are hard to see. Across from the 110, this would be 5.2 centimeters. Across from the 45 is 3.9 centimeters. And across from the 25-degree is 2.4 centimeters. So again, it will always happen that across from the largest angle, this will be the longest side. Across from the shortest angle, this will be the shortest side. And then obviously across the middle angle, it'll be the length that falls between these two. I can also take a right angle and try to find the same thing. So I have a 90-degree angle, and I drew a 55 here and a 35 here. Across from the 90-degree angle is 4 centimeters. Again, that'll be my longest side. Across from the 35-degree, it's 2.3 centimeters. This will be the shortest. So across the 55, this will fall between these two, and it does. So first of all, if I look at a picture, I could find this angle measure because I know the three measures have to add up to 180. So far I have a 47 and a 35, which gives me 82 degrees. All three have to add up to 180. So 180 minus 82. So instead of borrowing, I'm going to try to do this mentally. 180 minus 80 would be 100. But then I still need to take 2 off. So I know this angle is a 98-degree angle. So now they want me to list the side lengths from shortest to longest. I don't need to measure them. I know that the shortest will be across from the smallest angle. So across from 35, x will be the shortest. The longest will be across from the biggest angle. So that means the middle size angle, z, will be the middle length angle or side. Okay, so now we're going to get into exterior angles and interior angles and looking at some relationships. So they wanted me to name the interior angles. Interior angles are the angles inside the triangle, so obviously 1, 2, and 3. The exterior angle is an angle on the exterior of the triangle, so it makes sense that angle 4 is on the exterior. So if I go to answer question 4, what does the measure of angle 1, 2, and 3 equal? And explain? Well, we know that based on the triangle sum theorem, 3 angles of a triangle add up to 180. So I know those 3 angles equal 180 because of the triangle sum theorem. So now they ask, what's the measure of 3 and 4? Well, I see that 3 and 4 make a linear pair, or they're supplementary. So they add up to 180. So 180 degrees, they're a linear pair, or I could say they are supplementary angles. So now they're asking me, why then can they say that angle 1 and 2 is equal to angle 4? So I'm going to look at these relationships. If I know that angle 1 plus 2 plus 3 equals 180, and I also know angles 3 and 4 equals 180, then I know that angle 1, 2, and 3 will equal 3 and 4, because these equal 180, these equal 180, so they have to be equal to each other. So algebraically, I know I could take angle 3 out of both sides of my equals. So then I'm left with angle 1 and 2 equaling 4. If I want to kind of look at that in terms of the picture, if these 3 angles equal 180, and these 2 angles equal 180, they both have this in common. That means angle 4 must be the same as 1 and 2. Now there's a name for this. So this is called the remote interior angles of a triangle. That means that the remote interior angles are the 2 angles that are non-adjacent to the specified exterior angle. So for example, I'm going to draw my picture different from the one we were just looking at. Let's say this is 1, 2, 3, and 4. 1 and 4 are adjacent. So it says the 2 angles that are not adjacent to the exterior angle, this and this, they are not adjacent to angle 4. So 2 and 3 will be the same. If I add these two together, that's the same as this angle measure over here. So that's called the exterior angle theorem. The exterior angle theorem states that the measure of the exterior angle of a triangle is equal to the sum, addition, of the measures of the 2 remote interior angles. This one's the adjacent angle. The remote are the 2 that, think of the word remote. If you're on a remote island, you're kind of far away. These 2 angles are far from this one. This one's right next to it. So these are the 2 remote. So I can find this angle measure by finding the sum of these 2. 132 plus 21. So this angle measure is 153 degrees. Now I could have found it by saying, well, this plus this is 180, and then 180 minus this would give me back this. This allows me to get there in one step. I'm going to skip ahead a little bit. I can look at a problem like 14 then, and I could find this angle up here. If I know this is 93, that's the remote, or that's my exterior angle. The exterior angle is equal to the sum of the 2 remote, far away, interior angles. This angle's right next to it. So this angle's remote, and this angle is remote. I'm just going to call it A. Now I could solve. Minus 31 to both sides. So 62 degrees equals angle A. Okay, the last piece should be kind of obvious. It's called the exterior angle inequality theorem. So if I think about it, this exterior angle is equal to the sum of these 2. So this angle has to be bigger than this angle. It also has to be bigger than this angle because it's equal to these 2 put together. So that's what the exterior angle inequality theorem states that the measure of the exterior angle of a triangle is greater than the measure of either of the remote interior angles of the triangle. Again, it should make sense because this is equal to these two put together. So by itself, this angle has to be bigger than this one by itself, has to be bigger than this one by itself.